So we can run ahead now and take a look at some disk encryption. What we're going to be looking at here is full disk encryption, or encrypting the disk or encrypting the partition. So in itself this is not an encrypted file system. We would then go through and format the encrypted device. But this is the standard way of providing encryption for our disks within Linux, and most distributions have the package crypt setup that provides then LUKS. LUKS stands for the Linux Unified Key Setup. So we'll say we need the crypt setup package, and then we go through and format our device. This is not formatting it for a file system, this is actually encrypting it. And the idea of encrypting the device rather than the file system is then we won't get to see where the information is stored, because essentially we have data across the whole of the device rather than just where our data is stored. So as we look at this, we use encrypt setup -v, so we have verbose output. The -y is going to verify our passphrase when we put it in. Then our subcommand LUKS format, and then our device. But because we're writing to the complete device, if this is a large device, let's say 1 or 2 terabytes, then of course it's going to take perhaps several hours for it to complete as we write 1 or 2 terabytes of data. We then need to open the device and assign it a dev mapper name. So here we then use the subcommand LUKS open, and we're going to be prompted for our passphrase. We specify then the device and the dev mapper name. Here we're using secure, but it could be any name that you wanted. Of course, we should be able to list this device, so it's going to appear under /dev/mapper. And then, of course, we go ahead and format it. The LUKS format itself is only going through encrypting our device, so we need to create the file system. When we do that, in this case, with ext4, but you could use the file system of your choice. And then we need to mount it to be able to access our data. The LUKS open command is then enabling us to assign the dev mapper name. But during the boot phase, we're going to have to do the same thing again. So we can automate the process through crypt tab. And we have then the options to put the dev mapper name, the device, and the passphrase. Typically, we're not going to put in the passphrase because surely that defeats the whole idea of what we're trying to achieve with a level of security and privacy here, because then automatically we're able to access that file system. Whereas if we don't put in the passphrase, we're going to be prompted for the passphrase during the boot process. So typically for our system here, we would put something like secure, our dev mapper name, /dev/ste being the device, and then putting none just to specify that we're not putting the passphrase. As you also might guess from this, this leans more to the setup where we're using laptops rather than servers. So if somebody takes away a laptop from your organization, if they happen to leave it at a railway station, as MI5 are wanting to do, or leave it on a train, again, I think the higher up the civil service you are, the more likely you are to leave your laptop on the train, then at least the data is going to be protected. Of course, so long as there isn't a post-it note with the passphrase on the laptop lid. So let's look at how we can then provide this level of encryption by working on our CentOS 7 system. So we're back on our CentOS command line and we're cracking to go. So let's go ahead and run crypt setup. So -v for verbose, and then we can say verify our passphrase. So it's really saying that we're going to use a passphrase when we go ahead and use the LUKS format sub command. We could use other public key, private key mechanisms rather than using a passphrase. /dev/mapper dev/sde1. With that ahead, then we can say, yep, do we want to go ahead? And you can see that because we're writing then to the complete partition, if there is existing data, it's all going to be overwritten. So to be doubly sure, they're getting us to type then in uppercase, yes, we are prepared to destroy our data. Oh no, STE, I didn't mean that. So obviously make sure this is your correct partition that we're writing to. So we can set then a secure passphrase and then make sure that we typed it correctly, because of course there's no real way of overcoming this. But it also then provides a level of checking that we're using a secure passphrase. So as we go through and look here, that it's based on a dictionary word, so it doesn't like our passphrase. So if we go back and run this again, type in yes, but we have to then use something a little bit more secure. Now the time that this is going to take is very much dependent on the size of your partition. Mine's a virtual disk and it's only 1 gig, the partition. Of course, if it was longer, it's going to take longer to process, and also the disk speed is going to come in. But yet there we've gone through now. The LUKS format command is creating then the encryption. We now need to run crypt setup and LUKS open, and don't forget the mixed case that we use /dev/sde1 and then assign it a dev mapper name, so anything that's not currently in use. So of course we're being prompted for the passphrase, and I should have mentioned this before, it's very important that you remember it, because if you lose that passphrase, there's no way to be able to get back into that data. But if I use now the ls-l on /dev/mapper, then we should be able to see then all of those dev mapper names, and we can see that this then just becomes a symbolic link through then to the parent directory, so to the dev directory, and then the dev mapper 2 in this case, but assigning it our own name as we do then for our logical volumes makes it an easy way to be able to gain access through to this. We need to format it, so mukfs.ext4 or whatever file system you would like to use, and then /dev mapper and then secure. And now if we go through and create a directory, now again the name can be anything, but I'll just keep it to secure. We can then go through and mount this. And of course we're using the device being the dev mapper and then through to our directory. And that's pretty much it. We're able to access that now as a normal file system, and we have no real knowledge that that is encrypted. If we take a look underneath, if we wanted to, we could /etc/crypt tab. So the file is there, but it doesn't have anything in by default. But we could then go through and add in our dev mapper name. So that's going to be secure, the device /dev/sde1, and then typically we're going to put none for the password. So during the boot process, we're then going to be prompted for the passphrase. Let's jump back now to the slides so we can tidy up this section.